during the last lesson, we looked at examples on the. Firstly, we looked at the meaning or how to identify direct and inverse proportion.
Indirect.
Yeah, direct and indirect or direct and inverse. So we also looked at a few examples, trying to solve some questions. Now today, we're going to be focusing more on inverse. But before we go ahead, direct and inverse proportion. So what we have to say is inverse proportion. Inverse proportion. Yeah, somebody is talking on the front here. So we'll be looking at example of situation. Now let me say each and every one of you see a situation that we can consider as direct proportion. In your lab, what's an example of a direct proportion? Eniola? Yeah, what is an example of direct proportion? Yeah.
To compare
Yes.
compare the weather and the liquid alcohol.
The what? Okay, Isaiah, you tried direct proportion. Isaiah, let me see your face. Yes, direct proportion. Yes, over to you.
Is it direct proportion?
Give me an example of a situation or a question that you can see and you know this is direct proportion. Give me an example. There is underground noise from your side, I'm listening.
No side, not my side.
Is that not because I'm hearing? Okay, yes. Anyway, I will go over that again. When you are comparing two quantities and the two quantities increase, the first increase as the other increase, we say it is direct. Probably the two of you should be muted now. Mute yourself so that the noise will be reduced. And you just listen to the explanation. And as soon as I need you to unmute yourself, you're going to unmute yourself. Can you hear me clearly now? I think that's clear. Now, when you're comparing two quantities and one quantity increases as the other increase, then we call it direct. But if one decrease as the other increase, or one increase as the other decrease, we call it inverse proportion. I'm still hearing underground noise there. Isaiah. Mute yourself, let's Isaiah, okay now. So we are comparing two quantities. One increase as the other increase, call it direct proportion. But when one decrease and the other increase, or one increase and the other decrease, call it inverse. I'm going to give an example of inverse right away. If you're comparing the number of men that can finish a task in a given time. This is inverse proportion. Let us assume they want to mow a particular grassland. If there are 10 mowers, they're going to finish on time. And if I reduce the number of mowers, then the time given to finish the task needs to be increased. For example, if only one student is sweep one class. Yeah, it's going to take him maybe a particular number of minutes. But if that student is going to sweep 10 classrooms, it's going to be more. So the number of students that can sweep, like let's say 10 classrooms, vary in timetable. If a student is to sweep 10 classrooms, take him maybe 1 hour. Or if 10 students are to sweep 10 classes, it can take them just like 10 minutes. So we can say, as one quantity increases, the other decreases. So that is inverse proportion. We're going to be looking at some examples now. Looking at the examples. Example 1 under how to solve inverse. 1. When a quantity A is inversely proportional to B, and A is given as a number, while B is also another number, the value of B we have to be found when A is this, but the value of B is this. Let's see an example here and see how it is. So example 1. Put down the example, then unmute yourself so we can discuss. So, A is inverse. So unmute yourself. A is inverse proportional to B when A is 10, B is 2. Find the value of A when B is 8. So any other can do it. So both of you, okay, very good. Isaac, can you hear me now? Okay, in an attempt to solve this particular question, we're going to approach it just like we did during the solution to direct. But under the solution direct, we find that under direct, say A varies directly as B. But under inverse, A varies inversely as B. So the meaning of inverse is 1 over something. For example, 1 over F inverse. 1 over Z is the inverse. So here now, this relationship is going to be A varies inversely as B. At A varies inversely as B, I have A equal to the same constant we introduced times the inverse of B. And when you see that A equals what is K times 1 times K and all so here I want to find my constant. Find my constant, I'm going to cross multiply. So 1 times K is K and A times B is A B. That is, I cross multiply. Let me write it multiply. Yes. So here now, to find my K from the first set of values I was given. The first value of A is 10, while the value of B is 2. So that is 10 times 2. And that is going to give me 20. So that means my K is 20. What's the value of K then?
20.
Yes, 20. So since the value of K is 20, I can go ahead and put K into the formula. You know, the formula was A equals to K over B. K over B. So A is now equal to 20 over B instead of K. Now find A when B is 8. That means I'm going to substitute the new value of B. Now, 8. I'm going to say 8 equals 28. And I'm going to cut that down to the smallest value. So how many 4 is a 20? That is 5. So how many 4 is 8? 2. So the answer is 2.5.
And you are
2.5. So that is how to solve question on inverse proportion. So
proportion.
yes, there's a difference between inverse and direct. Direct doesn't need 1 over, but inverse needs 1. That's very good. So please put that down quickly so we can move on to the next example. Now to example 2. Example 2. Inversely proportional. Okay, so f is inversely proportional to the square of x. Let's see that. F, are you through with the note now?
Yes, sir.
Okay, so let me explain it and put this up straight away. So get ready. I'm still going to ask you to give me scenarios that we can consider whether direct or inverse. So just think about it while I put up the second example. So for example 2, here is what I have. I have f is inversely proportional to the square x. Now it's f and x, not a and b, so I'm going to change this to f. When f is 20, x is 3. So find the value of f when x is 5. I'm still hearing some background noise. Hearing some background noises there. So to solve this, we're going to follow the same method. Let me ask you one by one. Isaiah, what do you think should be the first thing I'm going to try for this solution? Yes. What is the first thing I'm going to write for this solution, Isaiah?
I'm going to write F.
F, Yes, inversely proportional to what?
1 over x.
No. No. Eniola, what do you suppose I write?
F is inversely proportional to x squared.
Very x squared. Isaiah, do you hear that?
Yeah.
So because you have to follow the question, square of x. This is what it is. Square of x. So you're going to now rewrite this as f equal to constant times 1 over x squared. Constant times 1 over x squared. So here now I have f equals to constant all over x squared. And I have been given the value of f and x, or I can find my constant by crossing the line. So k times 1 is k equal to f x squared. And what is the first value of f? Now it's 20. What is the first value of x? 3. That's 3.
20.
So that is 20 times, what's 3 squared? 9.
Square.
So that is, what's 20 times 9? 180. So with that, I have my k. So that k can go back to the relationship. I have f equal to k, which is 180 all over x squared. So now we're going to go ahead and find the value of x when x is 5. The value of x when x is 5. So here now, say f equal to 108 all over 5. So where did I get 5 squared? Daniela, where did I get 5 squared? This 5 squared, where did I get it from? Isaiah. This 5 squared. Yes, x is 5, and we are not using x, so we are using what? X squared. By using x, not x. That's why it's 5 squared, not 5. You know, was I given 5 squared in the question? No, we're given just 5. So that's what I'm pointing you to. It's going to be f 180. What is the square root of 5? I mean, what's the square of 5? Square of 5. That's 25.
Square of 5. 25.
25. Or I just say 5 times. Then I can cut it down and say 5 here, 1. 5 in 8 is 3. Remains that's 15. 5 in 30 is 6. So I have 5. Then I can still go ahead and cut front. So I can still go ahead and cut 5 here, 1. 5 in 36 is 7. And that 1, 5. Yeah. So that's all ready. So I'm going to give one question now. I'm not going to solve. So put that watch on screen. I'm not going to solve it. That will ask you. So let's say this example. Are you true now? Okay. So let me stop the example that I'll be asking the two of you. You are not going to write anything down during this study. But I'll be asking the two of you for the steps to be followed. For the steps to be followed. So let's look at this. Read the question, both of you.
It takes 4 men 6 hours to repair a road. How long will it take 8 men to do the job
now,
if they work at the same rate?
Okay, what can Isaiah read the question? Let me hear you.
4 men 6 hours to repair a road. How long will it take 8 men to do the job if they work at the same rate?
Okay, so what kind of proportion do you think this is, and why? Yes, tell me, Daniela, what kind of proportion do you think this is, and why? Yes. Is it going to be direct? Is it going to be inverse? Yes.
Direct.
Direct. Why?
Because one goes up and one goes down.
What is going up? What is going down? Forget about the figures you're looking at. Just tell me, what do you think is going up? What is going down?
The men are going up and the hours are getting up.
Why? How? So you mean if they increase the number of men, they increase number of men, what will happen to the time to finish the job?
The time will reduce.
So, and you call that direct? Inverse. It should be what?
Inverse proportion.
Inverse proportion. So, you knowing what kind of proportion you have at hand. Isaiah, are you listening? You knowing what kind of proportion you have at hand is a step to knowing how to solve it. Now that you know the inverse, so what are we going to say? Men versus hours. Men versus what? Men versus what? Hours. Very good. So men is inversely proportional to the number of hours. So I'm going to put a constant here. So M equal to constant over H, where my constant equals to MH. So takes 4 men 6 hours, and that is the constant rate, which is 24. So I can now say number of men in 6 equals to 24 divided by number of hours when it takes them. So we now say, okay, how long will it take 8 men? What is the question asking us to find? Is it asking us to find the number of men or the hours taken? You are not listening, you are busy writing. To find what?
The amount of like hours.
Yeah,
at the same
so
rate.
what are we looking for now? M or H? Isaiah,
We're looking for 8.
Yes.
We're looking
So
for 8.
So when you cross multiply, you have MH equals 24. MH equal to 24. Then you can divide by M to find your H. So M cancels out M. Then I have my H here. So it means the line here, I have my H to be 24 over M. So what is the new number of M now? That's 8. So what is the hours it's going to take them? That's 3 hours. So 24 over 8 is 3. So it's going to take them 3 hours to finish the job. So I believe that is clear to both of you.
Yes, sir.
Okay, very good. So after the class, I'm going to send you the lecture link so that you can at least go over it again. To do a quick recap, to identify the kind of proportion you are dealing with, you have to know, look at the quantities. Is one increasing and the other increasing? If yes, it is direct. But is one increasing and the other decreasing? If yes, it is inverse. And when it is direct, you use direct proportionality sign, like A direct B as B, A direct as B. And if it is inverse, you use A inverse B. So, is that clear to both of you? Is that clear now? Okay. So,
Yes, sir.
thank you very much. That is where we're going to be ending the class with. You do have a nice day ahead of you. Okay.